So hello everyone. Let us start with the next session, that is catalysts and reagent. So already we have seen question and answers, solved question and answers of catalyst and reagent. Now today we will be seeing at the objective questions such as MCQ, true or false, and match the pair, which are asked in the various entrance exams, BSc, then CET, GATE. So let us begin with our today's session. So this is Dr. Maheshwari Zirpe. Let us begin with the first, that is choose the correct option of the following. So the first one is dash is the component of Lindar's catalyst. So the option given are palladium on carbon, nickel with aluminium, palladium on calcium carbonate with lead acetate, and platinum oxide. So the correct option is C, that is palladium on calcium carbonate with lead acetate. As we all know that Lindahl's catalyst is nothing but palladium which is coated on calcium carbonate. So the next one, Lindar catalyst is used for selective hydrogenation of, the options given are alkyne to cis alkene, alkynes to alkanes, alkynes to trans alkenes, and alkenes to alkanes. So the correct option is A, that is alkenes to cis alkene, because as we all know that Lindahl's catalyst is used basically for partial reduction, and here you can find that alkynes having triple bond is reduced to double bond, but selectively we get cis alkene. Cis alkene, as cis alkene we will find that this Lindahl catalyst is having a selective hydrogenation. That means there is a syn addition taking place. So it is a stereo selective reaction taking place with the Lindahl's catalyst. Now the next is Adams catalyst is composed of. So basically Adam catalyst nothing but platinum dioxide. So the correct option is fourth. Okay. So let us see the next one, that is in Rosamond reduction, an acid chloride is reduced to an aldehyde. So Rosamond reduction, as we all know that acid chlorides are reduced to aldehydes. What is the catalyst which is used? So the catalyst is palladium, which is good with palladium and barium sulfate with hydrogen. So basically this is a reduction reaction, which is also known as Rosamond reduction. So you should always remember that Rosamond reduction has palladium and barium sulfate. The next is dash reagent is selective for reducing ketones and aldehydes and does not reduce esters or carboxylic acid. So please pay attention to this sentence very carefully, because it is saying that it is selectively reducing ketones and aldehydes and does not reduce esters and carboxylic acid. So basically all reducing agents you can see in the option. Only sodium borohydride is a catalyst which is going to reduce only ketones and aldehydes, okay, because it is a mild reducing agent. Now the next one is the function of barium sulfate in Rosamond reduction is dash. Previously we have already seen the fourth question where you have seen Rosamond reduction. So what is the function of barium sulfate? Here barium sulfate acts as a poison to prevent over reduction. Okay, so the option B is correct one. So let us go to the next one. Now next is dash type of reaction is facilitated by Adams catalyst. So Adams catalyst basically it is used for reduction. So you can see the options, and reduction means addition of hydrogen. So the correct option is C. C is hydrogenation. Now next question is metachloroperbenzoic acid, that is which is also called as MCPBA. It is used for dash. So here, as we already seen in the question and answers, the chloroperbenzoic acid is basically used for epoxidation of alkenes. So the correct option is B. The epoxide is formed on the alkenes. Okay, the double bond is going to convert into epoxide ring. Now the next one is the best reagent for the selective oxidation of primary alcohols to aldehydes without over oxidation. So without over oxidation, which of the reagent is going to reduce primary alcohols to aldehyde? So the options given are PCC, sodium borohydride, lithium aluminum hydride, and ranitidine nickel. So if you see the options, basically the pyridium chlorochromate, that is PCC, is going to use as oxidizing agent, which is not going to over oxidize. Only it will get converted into primary alcohol to aldehyde. So it does not convert into acid carboxylic acid. So reaction stops at aldehyde. Okay. So students, please remember that PCC, that is pyridium chlorochromate, is used for selective oxidation. Now the next one is the main difference between lithium aluminum hydride and sodium borohydride in reduction reaction is dash. So you will find options given here. So basically option A is the correct one. If you see the answer, it is lithium borohydride is stronger and reduces esters, whereas sodium borohydride doesn't. So in the previous fill in the blanks also we have seen that sodium borohydride can reduce only ketones and aldehydes. It cannot reduce esters and acid, whereas lithium aluminum hydride is a strong reducing agent, so it can reduce esters. Okay, students, please remember this. So, lithium aluminum hydride is a strong reducing agent, whereas sodium borohydride is a mild reducing agent. Now the next is red aluminium, sodium bis 2-methoxy ethoxy aluminum hydride is commonly used for dash. So the correct option is B, that is reduction of esters and amides. So basically to reduce ester and amides we can use red aluminium with sodium bis 2-methoxy methoxy ethoxy aluminum hydride. Okay. Now the next one is the most reactive reducing agent is dash. So the most reactive reducing agent is your lithium aluminum hydride among the given following options. Now the next is ranitidine nickel is used in dash. So once you see the word ranitidine nickel, you immediately it will strike that it is a reducing agent. So the hydrogenation of alkenes and alkynes can be done using ranitidine nickel. Okay, it cannot reduce aldehydes and ketones. So ranitidine nickel is basically used for hydrogenation of alkenes and alkynes. Now the next one is, what does metachloroperbenzoic acid preliminary do in organic synthesis? So basically we have already seen this question. Epoxidation takes place where alkenes are converted into epoxide. The correct option is B. What is ranitidine nickel? So ranitidine nickel, the word itself tells you the nickel. So it is a nickel with combination of aluminum alloy. So basically the correct option is A. It is having nickel and aluminum. So the alloy of nickel and aluminum is called as ranitidine nickel. We already seen the preparation of ranitidine nickel in our question answer session. Now the next one is N-borosuccinamide, that is NBS, is used for dash. So succinamide is, that is NBS, is used for bromination of benzylic to allylic and allylic positions. So bromination takes place at benzylic or allylic position depending on the starting material. Now the next one is selenium dioxide is a reagent used for dash. So we have seen in our question answer session, selenium dioxide is used for oxidation, but basically the oxidation takes place at allylic position. So the correct option is A. Now the next one, dash solvent is typically used for with NBS for allylic bromination. So when we were seeing question answers, complete the following reactions, you can remember that NBS is always used with a solvent, that is carbon tetrachloride. So the correct option is D. The next one, in Rosamond reduction of acyl halides barium sulfate and dash catalyst is used. So whenever you see Rosamond reduction, immediately it should strike that palladium is used in this. So palladium and barium sulfate. So the metal used here is palladium. The option D is the correct answer. Which reagent can oxidize sulfides to sulfoxides and sulfones? So the correct option is C, that is metachloroperbenzoic acid. C is the correct option. Now the next one, that is the last MCQ. The active methylene group can be selectively oxidized by. So which is the correct option which can selectively oxidize the active methylene group? So if you see the option, you can recall that selenium dioxide is a reagent which can selectively oxidize the active methylene group. Okay, so here we complete our MCQ session. Now let us move to the true or false. So whatever MCQ we have seen, based on that, if you can recall, you can easily answer true or false for the following. Lindar's catalyst is used for selective hydrogenation of alkynes to trans-alkenes. So we have already seen that Lindahl catalyst does selective hydrogenation, but it gives cis alkenes, not trans. So this statement is false. Adams catalyst consists of platinum dioxide and is used for hydrogenation reaction. So yes, this is correct because platinum dioxide is a Adams catalyst which is used for hydrogenation. Next is Rosamond reduction converts carboxylic acids to aldehyde using PD, that is palladium barium sulfate. So as we now, up till now, you must be knowing that palladium and barium sulfate is used for Rosamond reduction, but it is for what? It is for converting acyl chlorides to aldehydes, not carboxylic acid. So this statement is false. Okay, so here if it was acyl chloride, then the statement would have been true, but here they have given carboxylic acid, so the statement is false. Now the next is sodium borohydride is a strong reducing agent than lithium aluminum hydride and can reduce esters efficiently. So again, this is a false statement because in MCQ we already seen that lithium aluminum hydride is a strong reducing agent and sodium borohydride is a mild reducing agent. So fourth statement is false. Now the next one is red aluminium sodium bis 2-methoxy ethoxy aluminum hydride is a milder reducing agent than lithium aluminum hydride. So this is true. Okay, so lithium aluminum hydride is the strongest reducing agent. Then next is ranitidine is used for hydrogenation of alkenes and alkynes and nitriles under high pressure. So this is true. Okay, you can find that ranitidine can do the reduction for alkenes, alkynes and even nitriles. Okay, alkenes and alkynes, nitriles gets converted into amines under high pressure, atmospheric pressure. Now the next one is NBS, that is N-bromosuccinamide, is commonly used for allylic and benzylic bromination. So this is very much true. We have already seen this, that NBS is commonly used for bromination process. Now the next one is selenium dioxide is used for oxidation of benzylic and allylic positions. So this is true one. We have seen that selenium dioxide, it does a selective oxidation at benzylic and allylic positions. Now the next one is metachlorobenzoic acid is commonly used for epoxidation of alkenes. Very much true. The last one, ranitidine is commonly used in the oxidation of alcohols or to ketones. So this is false. We have already seen that ranitidine is used for oxidation of not alcohols, but it is used for reduction. So here itself you should see that when it is oxidation, ranitidine is always combined with reduction, not oxidation. So it is a reducing agent, so it cannot oxidize. So the statement is false. Now the next one is match the pairs. So you can see there are reagents given, reagents and catalysts given on one side, and the uses are given on the other side. So let us see the answers directly. Okay, if you want, you can pause this slide and try to match the pair. Okay, so let us go to the next one, that is the answers of match the pair. So Lindahl catalyst, it is used for selective hydrogenation of alkynes to cis alkenes. Okay, students, please remember it is cis alkenes, and Lindahl's catalyst does selective hydrogenation. Now the next is Adams catalyst. Adams catalyst is used, that is hydrogenation using PtO2, that is platinum dioxide. Then third one is Rosamond reduction. It is selectively reducing acyl chlorides to aldehydes. And whenever it is Rosamond reduction, you should always remember the catalyst, that is palladium with barium sulfate. Okay, next is sodium borohydride. Sodium borohydride is used for reducing aldehydes and ketones but not esters. Whereas the next one you can see red aluminum or lithium aluminum hydride. Fifth one, it reduces esters, carboxylic acids and amides also. Okay, so this is the difference between your mild reducing agent and strong reducing agent. Now the sixth one is ranitidine. Ranitidine is used for hydrogenation, that is reduction of alkenes, alkynes, nitriles and sulfides. Okay, so this match the pair is very important. If you remember this table, you can solve all MCQs of catalyst and reagent. Okay, next is seventh one is NBS, that is N-borosuccinamide, which is used for bromination at allylic and benzylic position. Then similarly, selenium dioxide, it is used for selective oxidation of allylic and benzylic positions. Then next, ninth one is metachloroperbenzoic acid, which is also known as MCPBA, which is used for epoxidation. Please remember this, children. MCPBA is used for epoxidation of alkenes. And the last one, this is but obvious, palladium with barium sulfate and quinoline. It is going, the reaction is Rosamond reduction, which is selectively going to reduce the acyl chlorides to aldehyde. So once again, student, best of luck for your examination, and try to remember this table so that you can solve many questions based on this table, which is match the pairs. Once again, best of luck and stay tuned. We'll meet once again for the next, that is complete the following reactions of catalyst and reagent. So please stay tuned, like the video and subscribe. Bye till then.